Welcome back, my dear students. In the last class, we have learned some of the properties of fluids, that is rho, what is that? Mass density, specific weight, specific volume, and also the specific gravity. So after knowing some of the properties of fluid, let us solve some of the examples, okay, to make sure that really we understood or not. Okay, so see, one of the example is given, that is calculate the specific weight. What we have to calculate? We have to calculate W. Density, we have to calculate rho, and also the specific gravity, yes, of what? Of 1 liter of a liquid. So 1 liter of a liquid which weighs 7 Newton. So what is given? Volume of liquid is given, and it is weighing 7 Newton. So whenever weight is given, it is given with including what? Gravity, that is 9.81, because it is given in Newton. Okay, so you must also know that 1 kg is equal to 9.80 Newton. So this basic thing will help you to solve the problem, that is 1 kg is equal to 9.80 Newton. I am writing from the mouse, so it is okay. 1 kg is equal to 9.80 Newton. It is okay. Remember this. Now we will solve the problem. So what is given? Volume is given, that is 1 liter. Volume is given. What we have to do? Whenever it is given in liter, we have to convert it to meter cube. So 1 liter is equal to 1 by 1000 meter cube. Okay. Next, weight is given, that is 7 Newton. Okay, so what is the weight of specific weight? It is Newton per meter cube only. Okay, can convert into different units, but will follow the standards. So specific weight W can be given in Newton per meter cube, so we will not change here. So weight is what? 7 Newton given. So whenever it is in Newton, we have to take the volume in meter cube. Because of the SI system, we have to follow the same pattern. So weight is 7 Newton, so volume is 1 by 1000 meter cube. So whenever we calculate, we will get the answer as 7000 Newton per meter cube as the specific weight. Next, what we have to find? We have to find the density. So what is density? It is mass per unit volume. Okay, here we don't know mass. Here mass is not given. Instead of mass, what is given? Weight is given. So we know a relation between specific weight, density and gravity. What is that? That is specific weight is equal to, that is density into what? G. Okay, specific weight is equal to density into G. What we want? We want the density. So we are sending G to this side, it becomes divisible. So now density, what we have? W by G. What is the specific weight we have got here? That is 7000 Newton per meter cube divided by 9.81 is the gravity G. So whenever we calculate, we will get 713.5 kg per meter cube. So what is the unit of the density? It is kg per meter cube. It is important. Units are very important. Please keep in mind. Next, what they are asking? They are asking to find us specific gravity. So what is specific gravity? Density of liquid to the density of water. Okay, when it is asking liquid, so we have to take the standard quantity as water only. So density of liquid, what is density? We are already found it, that is 713.5. So density of water, we already know, it is rememberable. Okay, please remember this. Density of water is 1000 kg per meter cube. So whenever we divide, we will get the answer specific gravity as 0.7135 as answer. Okay, so what they have given, they have given weight and liquid, and with that data we find out specific weight, density and gravity. Okay, now we'll move to the next slide. Now we shall see another example, second example. It is given as calculate the density, specific weight and weight of 1 liter of petrol of specific gravity 0.7. So same as earlier, the liquid has given here, petrol is given that much. Okay, and some data is missing, that is specific gravity has been given as 0.7. They need us to find the density and the specific weight and also weight of 1 liter of petrol. Okay, so what is the given? Volume. So volume is 1 liter, that is 1 by 1000 meter cube, or you can write it like this also. So 1 by 1000 meter cube is nothing but, it is just a conversion centimeter cube to meter cube. Okay, so specific gravity is given is 0.7. What we have to find? We have to find density. So in the example I have shown how, if specific gravity is given, how we will find density. We are just multiply with the density of water, that is S into 1000 kg per meter cube. What we are getting? 0.7 into 1000, that is 700 kg per meter cube. So once we get density, specific weight is easy, that is W is equal to rho into G. So what is weight density? Sorry, specific weight, it is 700. What is rho? Into G is 9.81. It will be 6867 Newton per meter cube. So we got density, we got specific weight. Now we have to find weight of 1 liter of petrol. Okay, so we know that specific weight is equal to weight per unit volume. So specific weight W is equal to weight, which we have to find. This weight is for what? Petrol. Okay, we don't know, we have to find the weight of 1 liter of petrol. But volume we know, that is 1 liter, that is 0.001 meter cube. So we got the specific weight as 6867, right? So if we use here, that is 6867 is equal to W by 0.01. So when we cross multiply, we are getting the weight of 1 liter of petrol is 6.867 Newton. So like this, we are solving the problems on properties of fluid. So everything is given, just we have to interchange, or we have to apply our common sense with the given formulas while studying the specific properties. So this was about the two examples on fluid properties. Now we shall move further. So next we shall see what is viscosity. Okay, so viscosity andre ಏನು? So viscosity is defined as the property of fluid which offers resistance to the movement of one layer of the fluid over another adjacent layer of the fluid. See here, before knowing what is viscosity, see velocity variation near a solid. Okay, here when two layers of fluid, here you think this two arrow marks are there, no? These are two layers of fluid. Okay, at a distance of dy apart, move one another. They will move with a distance dy. dy ಅನ್ನೋ ಡಿಸ್ಟೆನ್ಸ್ ಬಿಟ್ಟು ಎರಡು ಮೂವ್ ಆಗ್ತಾ ಇರ್ತವೆ. These are what? Layers of fluid. Okay, now the viscosity together with relative velocity causes a shear stress. So ಅವು ಫ್ಲೋ ಆಗುವಾಗ ಅವ್ರ ಮಧ್ಯೆ ಒಂದು ಎರಡು ಲೇಯರ್ಸ್ ಮಧ್ಯೆ ಒಂದು ಘರ್ಷಣೆ ಉಂಟಾಗುತ್ತೆ. So that ಘರ್ಷಣೆ is called as shear stress acting between the two layers between the fluid. Now the top layer, the top layer causes shear stress. This top layer ಇದೇನಿದೆ ಅಲ್ವಾ, this top layer causes shear stress on the adjacent lower layer, while ಮೇಲ್ಗಡೆ ಲೇಯರು ಕೆಳಗಡೆದ ಮೇಲೆ shear stress ಕೊಡುತ್ತೆ. ಹಾಗೆ this ಕೆಳಗಡೆದ ಲೇಯರು ಮೇಲ್ಗಡೆದ ಮೇಲೆ shear stress ಕೊಡುತ್ತೆ. But they will give some stress between shear stress between the two layers while flowing. Okay, when the friction will happen between them whenever there is a change in velocity, right? So see here, the first layer, this layer u, so we will make the layer, this shear stress, this layer is, the velocity of the layer is u, and the velocity of the upper layer is u plus du. Means what? ಈ ಲೇಯರ್ಗಿಂತ ಈ ಲೇಯರು ಸ್ವಲ್ಪ ಸ್ಪೀಡ್ ಆಗಿ ಹೋಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ಹಂಗೆ ಹೋಗುವಾಗ ಅದ್ರ ಮಧ್ಯೆ ಆಗುತ್ತಲ್ಲ ಘರ್ಷಣೆ, ಆ ಘರ್ಷಣೆ ಅದಕ್ಕೆ ಆಕ್ಚುಲ್ ಕಾರಣ ಯಾವುದು? ವಿಸ್ಕಾಸಿಟಿ ಅಂತ ಹೇಳಿ ಹೇಳ್ತಾರೆ. ಸೊ ಸಿ the top layer causes shear stress on the adjacent lower layer, while the lower layer causes shear stress on the adjacent top layer. Okay, this shear stress is proportional to the rate of change of velocity. ಸೊ ಅದೇನು ರೇಟ್ ಆಫ್ ಚೇಂಜ್ ಆಫ್ ಆದ್ರೆ ಅವೆರಡರ ಮಧ್ಯೆ ಏನು ವೆಲಾಸಿಟಿ ಡಿಫ್ರೆನ್ಸ್ ಇರುತ್ತಲ್ಲ ಅದಕ್ಕೆ ಆ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಪ್ರಪೋರ್ಷನಲ್ ಆಗಿರುತ್ತೆ. ಸೊ ದಿಸ್ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಇಟ್ ಈಸ್ ಡಿನೋಟೆಡ್ ಬೈ ಟೌ. This shear stress is proportional to the change of velocity with respect to y. Okay, mathematically we can tell that tau is proportional to dou u by dou y, athwa differentiation of u by differentiation of y, or tau is equal to, when this constant, when this proportionality is equated, we will get a new term, that is mu. So tau is equal to mu into du by dy. And what is this mu? Mu is called as the constant of proportionality and is known as coefficient of dynamic viscosity. Okay, so this du by dy, idenidella du by dy, this term is called the rate of shear strain, or rate of shear deformation, or velocity gradient, because it will tell the relations between velocity and also the distance between them. So from these equations we have mu is equal to this shear strain divided by du by dy. Okay, from which equation? From this equation. So ಏನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನು? ಫಸ್ಟ್ ಇಂದ ಹೇಳ್ತೀನಿ ಕೇಳಿ. ವಿಸ್ಕಾಸಿಟಿ ಅಂದ್ರೆ ವಿಸ್ಕಾಸಿಟಿ ಅಂದ್ರೇನು? ಇಟ್ ಈಸ್ ಡಿಫೈನ್ಡ್ ಆಸ್ ದ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ಫ್ಲೂಯಿಡ್ ವಿಚ್ ಆಫರ್ಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್. ಅದೇನ್ ಮಾಡುತ್ತೆ? ವಿಚ್ ಆಫರ್ಸ್ ರೆಸಿಸ್ಟೆನ್ಸ್, ಹೋಗ್ಲಿಕ್ಕೆ ಬಿಡೋದಿಲ್ಲ. ಸಮ್ obstruct it will create between two layers. Okay, viscosity is defined as the property of fluid which offers resistance to the movement of one layer of the fluid over another adjacent layer of the fluid. So it will, the property of fluid which offers resistance to the movement between the adjacent layer is called, this property is called as viscosity. Okay, our viscosity, so the resistance is called, no, so that property is called as shear stress, that is tau, and that tau is proportional to the rate of change of velocity with respect to y, and this shear stress is proportional to the rate of change of velocity with respect to y. When this proportionality is equated, we get a term called mu. So this mu is nothing but what? Constant of proportionality, and is known as coefficient of dynamic viscosity, or only viscosity. This is known as coefficient of dynamic viscosity. Now the term du by dy is called as the rate of shear strain or rate of shear deformation. So from equation we have this mu, the dynamic viscosity or only viscosity, is equal to what? Tau divided by the rate of shear strain. Okay, thus viscosity is also defined as shear stress, this is the shear stress, tau, required to produce unit rate of shear strain. Okay, so the viscosity is also defined as the shear stress required to produce unit rate of shear strain. So whenever you are going to write the definition, write this definition. It is defined as the property of the fluid which offers resistance between the two layers of fluid. Okay, now we shall go to next concept, that is unit of viscosity. So what is the unit? See here, we know that mu is equal to shear stress, that is what, mu is equal to what, tau divided by du by dy, right? So mu is equal to shear stress, tau divided by change of velocity, du is what, change of velocity, dy is what, change of distance. Okay, what is the shear stress? Shear stress is nothing but the force by area. What is the change of velocity? Change of velocity is nothing but the length per time into the distance is 1 by length. So now this length, so here, now what is this area? Area is nothing but the L square to the 2D elements. So force divided by length L square divided by 1 by time is equal to force into time by length square. So what is the SI unit? What will be the SI unit? What is the unit of force? It is Newton. What is the unit of time? It is seconds. What is the unit of length? It is meter square. So the unit of viscosity will be Newton second per meter square. Okay, what is the unit of viscosity? Very important, Newton second per meter square. Next we'll go for kinematic viscosity. So what is this kinematic viscosity? It is defined as the ratio between dynamic viscosity and density of fluid. Okay, this kinematic viscosity is the ratio between the dynamic viscosity and density of fluid. It is denoted by the Greek symbol nu. So mu is dynamic viscosity or simply viscosity, and this V is nu, and this is called as kinematic viscosity. So when does this kinematic viscosity exist? When this viscosity is divided by the density. Okay, just remember this, the kinematic viscosity is the ratio between the dynamic viscosity and density of fluid. So what is the kinematic viscosity unit? It is meter square per second. Okay, next we will see the Newton's laws of viscosity. So what does the Newton's laws of viscosity states? It states that the shear stress tau on a fluid element layer is directly proportional to the rate of shear strain. So the constant of proportionality is called as the coefficient of viscosity. This is already read. Okay, but it is termed as Newton's laws of viscosity. So it is nothing but what they are explaining this one. So what does the Newton's laws of viscosity states? It states that this shear stress tau on a fluid element layer is, this tau is directly proportional to the rate of shear strain, that is du by dy. Okay, this constant, whenever this equated to constant of proportionality, whenever it is equated, we will get a constant of proportionality mu, and this mu is called what? Coefficient of viscosity. So it's telling, so easy, right? So Newton's laws of viscosity. 1 minute. Okay, this was about Newton's laws of viscosity. Just you have to state that formula. It states that the shear stress on a fluid element is directly proportional to the rate of shear strain. So the constant of proportionality is called as coefficient of viscosity. So mathematically it is given by this equation you have to write. Now what are the Newtonian fluids and non-Newtonian fluids? So here see fluids which obey the above relation. Which relation? The relation given here, that is tau is equal to mu into du by dy. Okay, tau is equal to mu into du by dy. The fluids which obey the relation, this relation are known as Newtonian fluids, and the fluids which do not obey the above relation, that is tau is equal to mu into du by dy, is called as, which does not obey is called as non-Newtonian fluids, which obey are known as Newtonian fluids. So now we shall see the variation of viscosity with temperature. So temperature will definitely affect the viscosity because the temperature will act upon the molecules, how the matter is packed. If the matter is loosely packed, because of the temperature, it will, what it will do, gases, the molecule will randomly move. In the liquid, it the effect will be somewhat less compared to gas. Okay, so the viscosity of the liquid decreases. The viscosity of the liquid decreases with the increase of temperature, while the viscosity of gases increases with increase of temperature. Okay, the viscosity of liquids, ಲಿಕ್ವಿಡ್ದು ವಿಸ್ಕಾಸಿಟಿ ಟೆಂಪರೇಚರ್ ಜಾಸ್ತಿ ಆದಂಗೆ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ, whereas gases ಅಲ್ಲಿ temperature increase ಆದಂಗೆ viscosity of the gases will also increase. So this is the major difference between the liquids and gases. The viscosity in the liquid decreases with increase in temperature. ಅದೇ gases ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, it will increases with increase in temperature. So this is due to the reason that the viscous forces in the fluid are due to cohesive forces. So cohesive force ಅದರಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ, liquid ಅಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ, and molecular moment transfer. Okay, in liquid the cohesive force predominates the molecular moment transfer due to closely packed molecules. With the increase in temperature, the cohesive force decreases with the result of decreasing viscosity. So when there is no cohesive force only, then there is no question of shear strain. When there is no question of shear strain, there is no question of distance, and when there is no question of distance, viscosity will not be there. Okay, just you remember 3 points. What are these? The temperature surely affects the viscosity, and the viscosity of the liquid decreases with increase of temperature, while in gases it is increases with increase of temperature. Why? Because of cohesive force and molecular moment transfer. Okay, and okay, this point is enough for you. So next, but in the cases of gases, the cohesive forces are small. Okay, in the case of liquid, the cohesive forces are closely packed. Okay, the cohesive force is strong, but in the case of gases, the cohesive force are small and the molecular momentum transfer predominates. With the increase in temperature, the molecular momentum transfer increases, and hence viscosity also increases in the gases. So the relation between viscosity and temperature for liquid and gases are, so for liquids, see here, mu is equal to mu naught into 1 divided by 1 plus alpha t plus beta t square. So where mu is what? Viscosity of liquid at T degree centigrade, and these are all in poise. Okay, the unit of viscosity is Newton second per meter square. It's also called as poise. Okay, so 1 poise is equal to 1 by 10 Newton second per meter square. So where mu naught is what? Viscosity of liquid at 0 degree centigrade in poise. Alpha and beta are the constant for the liquid. So for example, for water, alpha naught means viscosity of liquid at 0 degree centigrade is 1.79 into 10 power minus 3. It is 10 power minus 3 poise. Alpha is 0.03368 and beta is 0.000221. So for gases, it is mu is equal to mu naught plus alpha t minus beta t square. It is square. Some technical mistake has been happened here. Okay, so just you remember this. So this is not so. Okay, just you remember the formulas. For liquids, mu is equal to mu naught 1 divided by 1 plus alpha t plus beta t square. And for the gases, whenever they ask about the variation of temperature, you have to write this, mention this equation, and you have to write what are the terms are there, what is mu, what is mu naught, what is alpha t. Okay, so mu is equal to mu naught plus alpha t minus beta t square. This is square. Okay, so this was about the variation of viscosity with temperature. Now we shall see the types of fluids. Okay, so what are the types of fluids? So we actually here in this fluid mechanics we have five types of fluids. So one is already visible, that is real fluid. We will come one by one. That is, first one is ideal fluid. So what is this ideal fluid? A fluid which is incompressible. So any fluid which is incompressible and is having no viscosity. Viscosity ನೇ ಇರಲ್ಲ, ಆಮೇಲೆ ಆ fluid ಕಂಪ್ರೆಸ್ ಆಗಲ್ಲ, is known as ideal fluid. ಸೊ ideal fluid ಏನಾಗುತ್ತೆ, ಯಾವುದೇ fluid ವಿಸ್ಕಾಸಿಟಿ ಇಲ್ಲದ್ರೆ ಅದು ಇರಕ್ಕೆ ಸಾಧ್ಯನಾ? ಇಲ್ಲ. ಸೊ ideal fluid is only an imaginary fluid, as all the fluid which exist have some viscosity. So see here, all the fluids which exist will have some viscosity. ಯಾವುದೇ fluid ನಮ್ಮ ನೇಚರ್ ಅಲ್ಲಿ ಇದ್ರೆ ಅದಕ್ಕೆ ಏನಾಗುತ್ತೆ, ವಿಸ್ಕಾಸಿಟಿ ಇದ್ದೇ ಇರುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಒನ್ is real fluid. A fluid which possesses viscosity is known as real fluid. All the fluid in actual practice are real fluid. So a fluid which possesses viscosity, here only in the first statement they have told that ideal fluid is only an imaginary fluid, and as all the fluids which exist. So which exists means what? This is real fluid. So a fluid which possesses viscosity is known as real fluid. So all the fluids in actual practice are real fluids. Next we'll come with the Newtonian fluid. So we already know what is Newtonian fluid. A real fluid in which the shear stress is directly proportional to the rate of shear strain, that is tau is proportional to du by dy, is known as Newtonian fluid. Next one is non-Newtonian fluid. A real fluid in which the shear stress is not, we have to use, it is not proportional to the rate of shear stress, shear strain, is known as non-Newtonian fluid. So we have ideal fluid which is incompressible and is having no viscosity. Then comes the real fluid which possesses viscosity. Then comes the Newtonian fluid. It is a real fluid which directly proportional to the that equation, or directly proportional to the rate of shear strain. And we have come across non-Newtonian fluids which is a real fluid but the shear stress tau is not proportional to the rate of shear strain. Next it will come the ideal plastic fluid. A fluid in which shear stress is more than the yield value and shear stress is proportional to the shear strain or velocity gradient is known as ideal plastic fluid. Okay, here the tau is more than the yield value. Whatever the yield we are getting, it is more than that. If the shear stress is more than the yield value and shear stress is proportional to the rate of shear strain, then it is called as the ideal plastic fluid. So these were the five types of fluids. So whenever we draw a graph between the shear stress, what is the shear stress? Tau, and du by dy. Okay, how these five fluids can be placed in that graph we'll show here. So see, shear stress tau is here and du by dy is the gradient. So it is in the x direction and it is in y direction. So what is this ideal fluid? What is this ideal fluid? A fluid which is incompressible and is having no viscosity. So viscosity ಇಲ್ಲ ಅಂದ್ರೆ ಏನರ್ಥ, ಎರಡು ಲೇಯರ್ ಇಲ್ಲ, ಎರಡು ಲೇಯರ್ ಮಧ್ಯ velocity gradient, there is no change in the velocity between that two layers. So velocity gradients ಇಲ್ಲ ಅನ್ನೋ ಕಾರಣದಿಂದ ideal fluid ಏನಾಗುತ್ತೆ, it will be in the x axis. So no value of what, no value of shear stress. Shear stress will be 0. Okay, this is ideal fluid. Then what is ideal solid? Shear stress will be maximum whereas velocity gradient will be 0. So this is ideal solid and this is ideal fluid. So remember this picture because it's gate bit also. Okay, in the exam gate it can be asked. They will draw or they will tell us to draw this, or they will just erase this and they will just show the graph and they will tell us to identify which graph is for which fluid. Okay, next after the ideal fluid which comes real fluid. So real fluid are these three are also the real fluid. Just we have to compare with the equation, right? Next, Newtonian fluid, a real fluid in which the shear stress, this shear stress is directly proportional. Okay, shear stress is directly proportional means what? This will be linear. So Newtonian fluid, see, whenever the shear stress is directly proportional to the velocity gradient, it will be a straight constant line. So it is linear. See here. The next, non-Newtonian fluid, a real fluid in which the shear stress is, it is not proportional. See here, the variation is not proportional, whereas here Newtonian fluid is proportional. Okay, so it is not proportional, so we have to draw like this. So now a real fluid in which the shear stress is not proportional to the rate of shear strain is known as non-Newtonian fluid. Next comes our ideal plastic fluid. What does it tells us? A fluid in which shear stress is more. Okay, so it is starting from here. Shear stress is more than the yield value, and after that yield value, after this yield value, shear stress is more than the yield value. After this, what? It is proportional to the velocity gradient. At initially it will not be existing, because the ideal plastic fluid is what? According to the statement, it is more than the yield value. After the yield value, it will be constant, it will be proportional to the velocity gradients. So these were the 5 types of fluids: ideal, real, Newtonian, non-Newtonian, and ideal plastic fluid. So next we will see another example on what we have studied till now. What is that? If the velocity distribution over a plate, so some velocity equation is given. So okay, equation is given, don't worry. Whenever you see equation, don't be in a confusion. It will be easy, very easy. If the velocity distribution over a plate is given by u is equal to 2 by 3y minus y square, in which u is the velocity in meter per second at a distance y meter above the plate, determine the shear stress at y. We have to determine the shear stress at y is equal to 0, and also we have to determine the shear stress at y is equal to 0.15 meter. Take dynamic viscosity of fluid as 8.63 poise. So what they have given? They have given an equation. So it is like now mathematics. So they have given an equation, that is u is equal to 2 by 3y minus y square. Okay, so we have to determine the shear stress. We have to determine what? Tau. So what we know, the tau formula, that is tau is equal to mu into du by dy, right? So because it is going to be differentiated, we have to differentiate this u, that is du by dy. What it will be? So differentiation of du by dy, 2 by 3 y will be 1 minus differentiation of y square is 2y, right? I'll show you. See here. So u is given, 1 minute, u is given, that is 2 by u is equal to 2 by 3y minus y square. So whenever we differentiate it, we will get 2 by 3 minus 2y. So they have given, we have to find that y is equal to 0. See here, y is equal to 0, and we have to find that y is equal to 0.15. So according to problem, du by dy at y is equal to 0, du by dy at y is equal to 0.15. Correct. Now take this equation, wherever y is there, you put 0. So 2 by 3 minus 2 into 0. So we'll get the answer 0.667. So du by dy at y is equal to 0. What is the answer of the shear strain? That is 0.667. Similarly, du by dy at y 0.15 ಎಷ್ಟಾಗುತ್ತೆ? ಎಲ್ಲಿ y ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ ಅಲ್ಲಿ ಏನು ಹಾಕಬೇಕು? 0.15 ಹಾಕಬೇಕು. ಹಾಕಿದಾಗ ಏನು ಆನ್ಸರ್ ಬರುತ್ತೆ? 0.367. So du by dy at 0 is 0.667, at 0.15 is 0.367. Then in the question they are also given that dynamic viscosity, that is 8.63 poise. They have already given the value of mu, that is 8.63 poise. So I already told you what is 1 poise. It is 1 by 10 Newton second per meter square. So same property is used here. See here, we have to convert. So value of poise is given 8.63 by 10. SI units is Newton second per meter square. Now shear stress is given by what we have to find. We have to find what? The shear stress. Tau we have to find. So shear stress at y is equal to 0. So tau naught. Tau naught means tau at 0. Mu into du by dy at y is equal to 0. So what is this mu? 0.863. They have given value. Just we have converted to Newton second per meter square. So du by dy no 0.667 we have found here. So multiply, you will get the answer. So what is the unit? Newton per meter square. So shear stress at y 0.15 meter is given by same, wherever the mu value is there, where we have to find 0.863, where du by dy at y is equal to 0.15, we have to add this 0.367. So we'll get the answer as 0.3167 Newton per meter square. So like this, problems will be given to you. Simple problems will be asked. So next example we'll see. Calculate the dynamic viscosity of an oil which is used for the lubrication between a square plate of size 0.8 meter into 0.8 meter and an inclined with an angle of inclination 30 degree as shown in figure. So the weight of the square plate is 300 Newton and it sides down the inclined plate with uniform velocity of 0.3 meter per second. The thickness of the oil film is 1.5 mm. Here see, the weight of the square plate is 300 Newton. Okay, and this plate with an inclination is given, means due to gravity it will come downward only. Okay, this type of problem you have solved in your first year wedge problem. Okay, remember that. So u is, what is that? 0.3 meter per second. It is inclined at 30 degree. So size of the square plate size have been given. Next, thickness is given. So every what is given, first note down it. So because in that only we will get the answer if we note down correctly. Then uniform velocity is 0.3 meter square. Okay, we'll solve the problem we have given. So what are the given? Area of the plate 0.8 into 0.8, we'll get the area as 0.64 meter square. Then angle of the plane. So inclination theta is 30 degree. Next, weight of the plane 300 Newton. Okay, see here 300 Newton is given. Okay, but this plate is not, what is that? This plate is inclined. Okay, so weight will be towards downward, right? So this is also 30 degree, this is also 30 degree. Okay, same like wedge problem only initially. So weight of the plate will be 300 Newton. So velocity of the plate is 0.3 meter per second. So what they have given? The thickness of the oil film they have given, that is dy, that is the thickness. Okay, 1.5 mm, that is 1.5 into 10 power minus 3 meter. We have to convert in SI unit. So let the viscosity of fluid between plate and inclined plane is mu. We know that. Okay, so this is the reason for the viscosity, right? So now component of weight W along the plane is W cos 60 degree. Why? I have told you, it is the same wedge problem. Okay, so component of the weight is W cos 60 degree, and what is W? That is 300 cos 60 degree, it is 150 Newton. So the weight of the square plate will be 150 Newton. Thus the shear force F on the bottom surface of the plate will be, the force due to the weight of the plate will be 150 Newton. So now using the equation, what is that? Tau is equal to, same equation we have to use. Before that, what is tau? Here tau is not given directly. Here weight is given, weight is converted into force, and force is divided by this area to get what? To get the shear stress tau. Okay, every basics, why basics are important? Because to solve this type of problems. So area of the plate ಕೊಟ್ರು, area of the plate ನಾವು ಮಾಡೋಂಥ ಪ್ರಾಬ್ಲಮಿಗೆ ಸಂಬಂಧನೇ ಇರಲಿಲ್ಲ. ಯಾಕೆ ಕೊಟ್ರು? Because they have not given the shear stress directly. Okay, we have to find that. So force ಎಷ್ಟು ಬಂತು? 150 Newton. Okay, so what is this? W6 cos 60 degree ಹೆಂಗ್ ಬಂತು? It is same like your wedge problem which you done in your second semester, right? Okay, now W cos 60 degree ಎಷ್ಟಾಗುತ್ತೆ? 150 Newton ಆಗುತ್ತೆ force component ಆಗಿ. Okay, thus the shear force will be 150 Newton. So force by area ಎಷ್ಟು ಬಂತು ನಮಗೆ? 0.64. So 150 by 1.64 ಮಾಡಿದ್ರೆ Newton per meter square. Correct? Now using the equation, what equation we know? We know only one equation, that is tau is equal to mu into du by dy. Okay, so change of velocity ಎಷ್ಟಾಗುತ್ತೆ? So initial velocity ಕೊಟ್ಟಿದ್ದಾರೆ. Okay, that is u. ಇನಿಷಿಯಲ್ ವೆಲಾಸಿಟಿ ಕೊಟ್ಟಿದ್ದಾರೆ, ಫೈನಲ್ ವೆಲಾಸಿಟಿ ಕೊಟ್ಟಿಲ್ಲ ಅಲ್ವಾ, ಅದಕ್ಕೆ 0 ಅಂತ ತಗೊಳ್ರಿ, ಟೆನ್ಷನ್ ಬೇಡ. ನೆಕ್ಸ್ಟ್ dy ಥಿಕ್ನೆಸ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? t. ಓಕೆ, ದಟ್ ಈಸ್ 1.5 into 10 power minus 3 meter. So now take this all values, substitute in this master equation, you will get the value of mu. What we have to find? The value of mu. See, calculate the dynamic viscosity, the value of mu they have asked. So when you substitute all the equation, that is your shear stress, that is 150 by 0.64, which is equal to mu. 0.3 is what? Du divided by thickness. We will get our dynamic viscosity as 11.7 poise. So what we are getting here also important thing. Okay, so I will do again this problem when I do the problem part. Okay, because when I write and explain to you, it will be understand better. Okay, it will be better, it will be easy to understand. Okay, so ಇಲ್ಲಿ ಏನು ಮಾಡಿದಾಗ, ಇಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದಾಗ ನಮಗೆ 1.17 ನ್ಯೂಟನ್ ಸೆಕೆಂಡ್ ಪರ್ ಮೀಟರ್ ಸ್ಕ್ವೇರ್ ಆಗಿ ಬರುತ್ತೆ. ಓಕೆ, ಇದನ್ನ ಬಂದ್ಮೇಲೆ ನಾವೇನು ಮಾಡಬೇಕು? ವಿ ನೋ ದ ವ್ಯಾಲ್ಯೂ to convert it into poise. So 1.17 into 10, 11.7 poise ಆಗುತ್ತೆ. So this is how we calculate. So next example, last example ನೋಡೋಣ. Here the space between two square flat parallel plate is filled with oil. Each side of the plate is 60 cm. The thickness of the oil film is 12.5 mm. So the thickness T is 12.5 mm. Each side of the plate is 60 cm. Fine. The upper plate, which moves at 2.5 meter per second square, requires force of 98.1 Newton to maintain the speed. Determine the dynamic viscosity of the oil and the kinematic viscosity of the oil if the specific gravity of the oil is 0.95. So whatever they have given, first note it down. Okay, it will be easy, but it's lengthier, that's it. So the space between two square plates, so they have given square flat parallel plates. Okay, so because of the square plate of 60 centimeter, so what is given? Each side of the square plate is 60 centimeter, that is 0.6 meter. What will be the area? Area of the square is 6 into 6 6 are 36, that is 0.36 meter square. Thickness of the oil film they have given, that is dy, that is nothing but 12.5 into 10 power minus 3 meter. So the velocity of the upper plate they have given, that is 2.5 meter per second. So u ಕೊಟ್ಟಿದ್ದಾರೆ, dy ಕೊಟ್ಟಿದ್ದಾರೆ, area ಕೊಟ್ಟಿದ್ದಾರೆ. Next we have to, however, we need to find force. Force is also given 9.98.1. okay, we have to find what? Dynamic viscosity, and we have to find nu. Correct? Nu ಏನು? Your dynamic viscosity by density. So ಇಲ್ಲಿ ಏನು ಬೇಕು ನಮಗೆ? We have to find the density also. We have to find. So next we will go. So change of velocity between the plates is du. 2.5 meter per second. So force required on the upper plate is 98.1. Same, shear stress is equal to tau is equal to force by area. So whenever we do 98.1 Newton by 0.36 meter square. So let mu be the, what the formula we are knowing. The only one formula we know is this one, tau is equal to mu is equal to du by dy. So what is tau? 98.1 but divided by 0.36 is equal to mu into 12.5 by 12.5 into 10 power minus 3. Calculate it. You will get the value of mu. That is what? 1.3635 Newton second per meter square. So after getting mu, what we have to find? We have to find what? Nu. How to find nu? It is the ratio of mu by density. Correct. Then they have given another value, that is specific gravity of oil is 0.95. So this value is given intentionally to find density. So what will be the value of density when the specific gravity is given? So specific gravity of oil is 0.95. Okay. So mass density of oil, yes, into 1000 is, I already told you, density of water. So 0.95 into 1000, 950 kg per meter cube. So using the relation nu is equal to mu by rho, we get nu is equal to 1.3635 Newton second per meter square divided by 950. We are getting the new value as 0.001435 meter square per second. So this was about the viscosity and some problems on the fluid properties. So next topics will be covered in your next sessions. Thank you.